What are the operations of sets? On sets we can apply, there are three type of operations which we can apply. One is a union of sets. Second is the intersection. And third is the difference between two sets. Okay, so these are three main operations which we can use on set. Now, what do we mean by union? Now, union. Let me first talk about union of two sets. Union of two sets. Let A and B be two sets. Then A union B is denoted like this, okay, which actually means that it is actually a set of all elements which are either in A or in B, okay, or in B, okay. So for example, if you say you have A which looks like 1, 2, 3, 4, and you have B which looks like 2, 4, 6, 8, then what would be A union B? A union B will be all the elements which are either in A or B. So 1 is there, 2 is there, 3 is there, 4 is there, 6 is there, 8 is there, okay. Now, when you look at union of two sets, it actually gives us two very important points per se. When you are talking about union of two sets, then actually when you look at A union B, A will always be a subset of A union B. Also, B will always be a subset of A union B. Why? Because all the elements in A are there in A union B, and all the elements in B are also there in A union B, right? Okay. And second very important point, that if A is a subset of B, okay, if A is a subset of B, then A union B equals to B. Just look at, I'll show you through a diagram. If this is A and this is B, okay. Now B is completely contained in A. What would A union B be? Now A union B is essentially all the elements which are there either in A or in B. Okay, either in A or in B. So as you see, this would be A union B. A union B is actually equal to it's actually equal to in the diagram I've written something wrong here. Basically B. A is a subset of, if A is a subset of B, if B is a subset of A, then that would have been A, okay. Now if A is a subset of B, then this will happen, okay, because this is A, this is B. Now the union is complete this part, which is actually just B. So that would happen. Now, what do we mean by intersection? Intersection is the common part. It's denoted as a inverted UB, which essentially is a set of all x's such that x is both in A and in B, okay. It's in both these. So if you have two sets like these, you see there is no intersection at all. They're not meeting anywhere. They do not have anything in common. In case you have this, then this is the common part, and this is the intersection of these two sets. Now, in the example we dealt with here, let me look at this example itself. Let us just take it here. Now, what would A intersection B would be here? 1, 2, 3, 4, 2, 4, 6, 8. What is the common thing in 2? In these two sets, it's 2 and 4. So, the intersection has two elements, 2 and 4. Okay. What about difference in two sets? Difference between two sets, that is A minus B. Okay, A minus B. Now, if A and B are two sets, okay, two sets, then A minus B essentially would be set of all elements which are there in A, but are not there in B. Okay, so in case you have, this is the diagrammatical representation of A minus B. All elements which are there in A and are not in B, okay, would just be the elements out here which are not there in the intersection out here. Okay, so that would be the difference between two sets. So what is the difference between these two sets given here? Let us just take the same example and see what would A minus B look like. So A minus B essentially is everything that is there in A but not in B. So 1 and 3. 1 and 3. Okay. Now remember one thing. A minus B does not equal to B minus A. Okay, in this example itself, A minus B is 1, 3. And what is B minus A? B minus A would be all the elements that are there in B but not in A. So, which is 6 and 8. So, this is a different set than A minus B.